Today we'll start electric dipole. So what is electric dipole? Two equal and opposite charges separated at a small distance is called an electric dipole. So suppose there are two charges, minus q and plus q. Both are equal and opposite charges. They are separated at a very small distance 12. This is called electric dipole. Then an electric dipole is ideal if magnitude of charges is very large and separation between them is very small. That is, when q tends to infinity and 12 tends to 0. This is the condition for ideal dipole. Dipole ideal kete bole habo? Magnitude of charges very high. That means magnitude of charges tends to infinity. And distance is very small. That means 12 tends to 0. So this is called an ideal dipole. Now, how to measure dipole? The effect of dipole is measured in terms of dipole moment. Next we'll go for electric dipole moment, denoted as P. So what is electric dipole moment? It is a vector quantity whose magnitude is equal to product of magnitude of either charge and distance between the charges and direction is from negative to positive charge. So let this is the dipole. Our dipole moment kete haba? Dipole moment is P. Now P is a vector quantity. So vector magnitude achi, direction achi. So magnitude kete haba? Product of magnitude of either charge and distance between the charges. So P equal to product of magnitude. दीटा जाक चार्ज रो magnitude केते अछि? Q अछि. जे कोनोसी गोटे चार्ज रो magnitude into distance between the charges. Now 12 रो direction हमें कुआडे नउचे? नेगेटिव रु पॉजिटिव आडो. Direction कुआडे रहइबो? From negative to positive. So its direction is from negative to positive charge. Then we will go for unit and dimension of dipole moment. So first we will go for dimension. So dimension of P will be dimension of Q into dimension of 12. Dimension of Q is A1 T1 and dimension of distance is L1. So dimension of P will be M0 L1 T1 A1. This is the dimension of dipole moment. Now if we go for SI unit, the SI unit of dipole moment is, dipole moment equal to Q into 12, that is charge into length. So SI unit is Coulomb into meter. Next we'll go for electric dipole in a uniform electric field. Now, let there is a uniform electric field E. An electric dipole. It is minus Q, it is plus Q, and length is 12. Now the dipole moment is P. This dipole moment makes an angle theta with the electric field. Now, what is the force on this charge? The force F will be QE. But this is a positive charge, so the force will be in the direction of electric field. Now, what is the force on this charge? Here, magnitude of charge is Q and electric field is E. So, the force is F equal to QE. But this is the negative charge, so the force will be in the opposite direction of electric field. Now, the net force on the dipole. The force on the dipole on the positive charge is QE in the direction of electric field, and the force on the negative charge is QE in the opposite direction of electric field. So, the net force on the dipole in a uniform electric field is 0. So what is the net force? The net force is 0. But two equal and opposite forces acting along different lines of action will produce a torque on the dipole. The torque acting acting on the dipole is given by tau equal to magnitude of either force into perpendicular distance between lines of action of the forces. So torque formula kona? Magnitude of either force into perpendicular distance between the line of action of the forces. Now, what is the magnitude of either force? Dita jaka force magnitude same achi, that is equal to QE into perpendicular distance find kariba ka ka bhitere dita force line of action bhitere. So a force line of action eta, a force line of action this. Anko bhitere perpendicular distance kuda haba eta na nahi. So we have to find, let this is A, this is B, this is O. So हमको कौन दरकार? A length दरकार. This length is OP. So it is equal to QE into OP. Now go for the triangle OAB. A triangle टा देखो. एटा 2L अच्छी, एटा theta अच्छी. If this angle is theta, this angle is also theta because they are corresponding angles. Now in triangle OAB, sin theta equal to कहते हैं OB by OA, that is OB by AB, that is equal to OB by AB is 2L, that implies OB equal to 2L sin theta. Now substitute here. That implies torque will be QE into 2L sin theta. That implies torque equal to Q into 2L into E sin theta. So torque equal to Q into 2L equal to dipole moment P. So torque equal to P sin theta. Now torque is the product of dipole moment and electric field. But dipole moment is a vector, electric field is a vector, and torque is also a vector. Product of two vectors produces a vector. Then the multiplication must be a vector multiplication. So in vector form, we can write torque equal to P cross E. P cross E will be P sin theta. Next we will go for work done by rotating the dipole. So now this is the uniform electric field E. So initially the dipole is at a position theta. Now I rotated the dipole to a position theta f. Initially theta ए पोजीशन में था, मैंने इसको थीटा ए पोजीशन तक रोटेट किया. So let I am rotating the dipole and at any instant it is at an angle theta. If I give a small displacement d theta, then the work done dw equal to tau d theta, but tau equal to how much? P sin theta. So dw equal to P sin theta d theta. So total work done equal to integration of P sin theta d theta, but the angle rotated, it is rotated from initial angle theta I to final angle theta f. So the limit is from theta I to theta f. So now P and E are constants. It will be integration of sin theta d theta from theta I to theta f. Now integration of sin theta is minus cos theta. If we take minus sign out, it is minus P cos theta f minus cos theta I. If you multiply minus inside the bracket, it will be P into cos theta I minus cos theta f. So work done equal to P into cos theta I minus cos theta f. Next we will go for potential energy of the dipole in uniform field. The potential energy of the dipole in uniform field is defined as the work required to rotate the dipole from zero energy position to its respective position. So the dipole is inclined at an angle theta with the electric field. Now जीरो एनर्जी पोजीशन से यहां तक रोटेट करने के लिए जितना वर्क करना पड़ेगा, दैट इज इट्स पोटेंशियल एनर्जी. जीरो एनर्जी पोजीशन एबे कोडा हबो, जीरो एनर्जी पोजीशन is selected when dipole moment is perpendicular to electric field, that is theta equal to 90 degree. So what is the meaning of potential energy? Let this is the uniform electric field. The dipole it is at an angle theta. Consider the dipole is once perpendicular to the field. तो A2 A position जाए rotate करिया पाए जेती की work करिया को पड़ला, that is the potential energy. Now initial position here it is 90 degree. Final position that is theta. So what will be the work done? P into cos theta initial minus cos theta final equal to P into cos 90 minus cos theta. So work equal to minus P cos theta because cos 90 is 0. This is the potential energy. So U equal to minus P cos theta. Now in vector form, we can write U equal to minus P dot T. This is the formula for potential energy. Now alternatively, you can derive it from the formula. So instead of writing this, you can write like this also. dW equal to tau d theta. It is equal to P sin theta d theta. So potential energy equal to what done? That is equal to integration of P sin theta d theta. Now limits will be from 90 degree to theta. Just put. So you will get U equal to P integration of sin theta is cos theta from 90 degree to theta. So U equal to P into cos it is minus cos theta. So U equal to minus P cos theta minus cos 90. So U equal to minus P cos theta. Now in vector form, U equal to minus P dot D.